We are asked to find all of the exact solutions to the following equation: cosine of x plus 5 pi over 6 equals 0, and to list those solutions of this equation which are in the interval 0 to 2 pi. So let us let theta equal x plus 5 pi over 6 and rewrite this top equation as cosine of theta equals 0. Which angles on the unit circle have a cosine value of 0? Those are pi over 2 and 3 pi over 2. So theta equals pi over 2 plus 2 pi k, and theta equals 3 pi over 2 plus 2 pi k. Let's substitute x plus 5 pi over 6 back into the theta values. X plus 5 pi over 6 equals pi over 2 plus 2 pi k, and x plus 5 pi over 6 equals 3 pi over 2 plus 2 pi k. And let's isolate x by subtracting 5 pi over 6 over to the other side for both of these equations. So we get x equals negative 2 pi over 6 plus 2 pi k, and x equals 4 pi over 6 plus 2 pi k. So these two equations are how you can represent all of the infinitely many solutions that this equation over here has. But we are asked to only list those solutions which are on the unit circle, so they are within 0 and 2 pi. So if I rewrite 2 pi with the denominator of 6, I can get an idea of where I should stop substituting whole number values into k. So I get 12 pi over 6. My values that I'm going to test cannot surpass 12 pi over 6. So let's start substituting whole number values into k for both of these equations. If k equals 0 in this equation, our solution is negative pi over 3, which is below 0, so it's not within this interval, so we cannot use this value. And if we substitute k as 0 into this equation, we get 2 pi over 3, which is within this interval. It's on the unit circle, so we can use that value. If k equals 1 in this equation, we get 5 pi over 3, which is on the unit circle, so we can use this. And if k equals 1 in this equation, we get 16 pi over 6, which is past 12 pi over 6. It's not on the unit circle, so we can't use this value either. So when they ask us to list those solutions which are on the unit circle for this equation, we get 2 pi over 3 and 5 pi over 3.